In this video, we're going to talk about trigonometric functions and its applications. Starting with example 1, draw a right triangle, pick an acute angle T, and label the sides of the triangle with adjacent, opposite, and hypotenuse. So let's do a right triangle. I'm going to do a right triangle that looks like this. Okay, and then mark the 90-degree angle. The two legs form 90 degree. Those are the two sides that we will label as adjacent and opposite. But in order to label which side is adjacent, which side is opposite, we need to find the angle first. And notice that the instruction mentioned this word right here, acute, right? An acute angle is an angle that's between 90 and 0 degrees. So in that case, it cannot be the 90 degrees that we have. So it cannot be this one, but it has to be the other one of the other two angles. And which one do you label? It's okay. Either one is fine. You just pick one to label, and that's how you know which side is adjacent, which side is opposite. I'm going to label this side, this angle as my angle T. And then based on this angle T, you have to look at which side is adjacent, which side is the opposite. The opposite is probably the easiest one to find. So you check out this angle and then you see which side it is opposite to, right? So apparently this is opposite to this side right here. So this is the opposite. Let's label that. Okay, and then the other side, the other leg, has to be the adjacent. So technically, there are two sides adjacent to angle T, right? One is this side, that's adjacent. The other one is this side. So why do we label this side? Is because opposite and adjacent, they are the two sides that form 90 degrees. And then finally, we have the last label, which is the hypotenuse. That one has to be the longest side in a right triangle. And it's always going to be this slanted side for the hypotenuse. So to summarize, in order to label the three sides of a right triangle using adjacent, opposite, and hypotenuse, you need to know which angle you're looking at, okay? So if I'm looking at this angle, then I have my opposite side right here, I have my adjacent side right here, and my hypotenuse right here. Okay, very good. Next, we're going to move on to practice 1. Practice 1 is the introduction of the 6 trigonometric functions based on this right triangle that we just created. And I have a little thing for you to remember, which is right here, SOHCAHTOA. So that's how you pronounce this. And how do you use this, right? You're going to first start with the capitalized letter. See the capitalized letter, we have S, C, and T. Those three refers to the three main trigonometric functions. Let's write them down. So we have sine, and then we have cosine, and then we have tangent. And I use the initial, as you can see, S, C, T. That's where the SCT comes from. They're referring to sine, cosine, and tangent. There are the three main trigonometric functions that you will use in this class. But since there are 6, there will be 3 more. We will talk about that after we finish discussing these 3. Next, I'm going to talk about the symbols that we use to label these 3 trigonometric functions. For sine, we use sin, and then followed by the angle. Notice that the angle that we chose is T, right? That's the symbol. So I'm going to use sine of T. So you could just put it right here. You could also put optionally parentheses right here if you want to make it a little bit more obvious for you to see that T is the angle and then sine is the function name. So this is sine of T. That's what it is. And then similarly for cosine, we're going to use cos. And then followed by the angle, which is T. And then don't forget, you could also do parentheses right there so that it doesn't look like the word cost. It's not cost, right? It's cosine of t. And then finally, we have tangent. Tangent, you probably guessed it. It's going to be tan of t. And of course, we're going to use parentheses. Tangent of t. And now we have these three notations representing the three main trigonometric functions. Trigonometric functions is defined as the ratios of the sides in a right triangle. So let's start with the sine. Sine, if you look at the SOHCAHTOA that I highlighted, it's SOH, right? So that means you're going to do O and H. O and H will tell you which two sides you're going to do to form a ratio. Ratio means division. So you're going to divide O by H. Let's write it down. This is O divided by H. And then what is O, what is H, right? Look at the right triangle that we labeled. O is opposite. So I'm going to just do OPPO. And then H is the hypotenuse. I'm just going to do HYPO just to save some of the writings. And you could do the same thing. Just remember, OPPO represents opposite side, and then HYPO represents the hypotenuse. And that comes from the SOHCAHTOA. So that's why SOHCAHTOA is a very nice way for you to quickly remember how you define those three trigonometric functions using a right triangle. And then next one is cosine of t. Cosine of t, follow the SOHCAHTOA. According to that, you're going to do A divided by H, right? So let's write that down first. A divided by H. And then what is A? According to the right triangle, it's adjacent. I'm going to do ADJA. And then H is, again, the hypotenuse, HYPO. So that's how you define cosine. Next, tangent. According to SOHCAHTOA, tangent is O divided by A. Let's do that. You have O divided by A. And then look at the right triangle. What is O? O is opposite, so OPPO. And then A is adjacent, ADJA. Okay? And I would say, remember these three main trigonometric functions, because you're going to use that for the remainder of the semester. And the way to remember it is using SOHCAHTOA, okay? Okay, so since there are 6 trigonometric functions, and we talked about the 3 of them, what are the other 3? The other 3, I usually like to define them as the reciprocal of these 3 main trigonometric functions, and I like you to remember them in pairs. Let's start with the first one. First one, sine. You're going to remember this along with its reciprocal, which is cosecant. Let's write the name of the function first, cosecant. So COSECANT, cosecant. And the symbol for this, you might think, should we use COS? That will be a trouble, right? Because we already have COS right here, so you can use COS. The symbol that we use is a little bit different this time. It's going to be CSC. This is because we can't use the first 3 letters as we did before with the sine, cosine, tangent. The COS already exists, so we have to change to something else. And the one that we typically use is CSC. That represents cosecant. And again, we're going to follow by the angle T. And then you're going to put parentheses around the angle. And since this is the reciprocal of sine, you simply flip this upside down. Because our sine is opposite divided by hypotenuse, then your cosecant is hypotenuse divided by opposite. And do you need to remember this? Not really. The only thing you need to remember is that sine and cosecant, they are reciprocals of each other. So that means if you know the value of sine, you will know the value of cosecant. So this formula is optional. You don't have to remember it. You just need to remember cosecant is the reciprocal of sine. Next is the reciprocal of cosine. The reciprocal of cosine is secant. And then this time we can use the first three letters, SEC in secant. This name has not been taken, so I'm going to do SEC of t, and of course I'm going to add parentheses. And then by the reciprocal of cosine, cosine is adjacent divided by hypotenuse, so secant is hypotenuse divided by adjacent. Okay, next one is the reciprocal of tangent. The reciprocal of tangent is called cotangent. Let's write down the name. And then the function name, you could use the first three letters, COT of t. And notice that the parentheses here is very useful, right? Because otherwise you're going to have COTT. So in the past, a lot of people got confused with these two function names. One is the COS, the other one is COT. Just remember that they are different, okay? COS represents cosine, COT represents cotangent. They're two different trigonometric functions. And by the definition of reciprocal, since cotangent is the reciprocal of tangent, tangent is opposite over adjacent, then cotangent has to be adjacent over opposite. All right, and now we completed the introduction of the 6 trigonometric functions for the angle t. And then we also have the graph right here. And so I highly recommend that you focus on these two problems first. Do a quick memorization if you can, especially the SOHCAHTOA, before you move on to other problems on this handout, because you will use this frequently. Okay, moving on to example 2. Given the triangle below, find the values of all 6 trigonometric functions evaluated at angle alpha. Let's first locate angle alpha. We have a right triangle. Angle alpha is right here. And I'd like you to label this right triangle with adjacent, opposite, and hypotenuse. So you could pause the video, do the label first, and then restart, see if you labeled it correctly. All right, so I assume that you labeled it correctly. So how do you label it, right? I think for most people, you will probably do the hypotenuse first, because the hypotenuse is pretty easy to see. It's the side that's opposite 90 degrees. So this one is the hypotenuse. I'm just going to do HYPO. And then the adjacent and the opposite, they're determined by where the angle is, right? Our angle is right here. So the opposite is this side, which is the 8. And then let's label that. So this will be the opposite. And then we have the remaining side adjacent. Okay, and then once we have all these 3 sides, we can create our 6 trigonometric functions. Just follow the SOHCAHTOA. I recommend you do those 3 main trigonometric functions first. I'm going to do sine of alpha. So this time the angle label is alpha, not t anymore. That's why I use alpha right there. And I also put parentheses around the alpha just to make it easy for us to see which angle it is. And according to SOHCAHTOA, sine is opposite divided by hypotenuse, right? So you just look at the right triangle. Opposite is 8, hypotenuse is 17. And that's it. Next is cosine. I'm going to do cosine of alpha. And according to SOHCAHTOA, cosine of alpha will be adjacent divided by hypotenuse. Adjacent is 15, hypotenuse 17. And then we have tangent of alpha. Tangent of alpha is opposite divided by adjacent. That would be 8 divided by 15. Okay, and then for the other 3, use pairs and then write the reciprocals. So sine, the reciprocal is cosecant, CSC. of alpha. And this one, you don't need to use the formula again. You just need to look at sine and then take a reciprocal. Since sine is a over 17, cosecant will be 17 over 8. All right, and then for cosine, its reciprocal is secant. So you're gonna do sec of alpha. It's the reciprocal of cosine, so it will be 17 over 15. And finally, the reciprocal of tangent is cotangent, COT, of alpha. Since tangent is a over 15, cotangent will be 15 over 8. Okay, I'd like you to use practice 2 as a practice. So pause the video, find all 6 trigonometric function values at angle T. Okay, hopefully you finished. So let's check your answers. I'm going to write down all of the answers. Sine of t is 7 over 25. Cosine of t, 24 over 25. Tangent of t is 7 over 24. These 3 main functions, if you get them right, then chances are you will get the other 3 right as well. Next is cosecant of t. It's 25 over 7. And then secant of t is 25 over 24. And finally, cotangent of t is 24 over 7. So check your answers, see if they are right. If they are not right, go back and check where you made your mistake. And I will do these 2 problems repeatedly until you mastered these 6 trigonometric functions, how you get them from a right triangle. Okay, because this is like the foundation of trigonometric functions, and you definitely need to know this in order to do other problems. Moving on to example 3. Given the 30, 60, 90 triangle, find the exact value of the trigonometric functions of pi over 3 and pi over 6. Also, how are the results related? So this one include a few things that we will discuss. The first thing is angles. In the previous handout, we discussed the conversion between the 2 kinds of angles, right? You have the degrees and you also have the radians. The angles that they use right here, they used both. So first, this 30, 60, 90, this is in degrees. So it's basically talking about you have a right triangle and the 3 angles inside. There are 30 degrees, 60 degrees, and 90 degrees. If you add them, they do get 180. The other angle measures, they used radians, right? You have pi over 3 and pi over 6. And I think for most people, the degrees measurement is probably easier to understand. So I will recommend that you convert pi over 3 and pi over 6 to numerical degrees first. So the conversion that we did last time is you divide 180 by 3, we divide 180 by 6, right? So basically replace pi with 180 degrees. And then you calculate. So pi over 3 will be 180 divided by 3, which is 60 degrees. And then pi over 6 will be 180 divided by 6, which is 30 degrees. Okay? So those are the 2 angles that we're trying to find. And now I'm going to do a graph of this right triangle. Okay, so this is my right triangle. I have my 90 degrees. I'm going to label my angles. This one is my 30 degrees, and this one is my 60 degrees. And you have the 90 degrees there. So this is called the 30, 60, 90 triangle. Why do we pay so much attention to this triangle is because it's a special right triangle. It has a fixed set of ratios of the sides. So starting with the 30 degrees, the opposite side, we're going to define it as a 1. So this side is a 1. And then the hypotenuse is twice of 1. So that will be 2. And then you could use the Pythagorean theorem to find out the remaining side. So if you do use that, the remaining side is computed to be square root of 3. These are the three ratios that you should definitely remember. In a 30, 60, 90 special right triangle, it's 1, 2, radical 3. And I already showed you how you can remember it. You start with the 30 degrees angles, okay? And then you do the opposite, make it 1. And the hypotenuse is 2. And the remaining side, if you don't remember, you could use the Pythagorean theorem to find out. It's going to be square root of 3. But it's better if you could remember it. So this is the 30, 60, 90 triangle. And once we have all the sides labeled, you should be able to calculate all 6 trigonometric values. Let's start with the first one. So I'm having sine, right? Sine of pi over 3. So remember, pi over 3 is 60 degrees. So you're looking at 60 degrees in the right triangle. And SOHCAHTOA, sine is opposite divided by hypotenuse. So that would be radical 3 divided by 2. And then we have cosine of pi over 3. And again, we're looking at 60 degrees. Cosine, SOHCAHTOA, cosine is adjacent divided by hypotenuse. So in this case, will be 1 over 2. And then tangent of pi over 3 is opposite divided by adjacent. So that will be radical 3 divided by 1, which is radical 3. Okay? And then we have the reciprocals, right? So we could write down the reciprocals. So the cosecant of pi over 3 will be the reciprocal of sine. So that will be 2 over radical 3. And then if we rationalize this by multiplying both sides, both the top and the bottom by radical 3, we get 2 radical 3 over 3. And then we have secant of pi over 3. That's the reciprocal of cosine. So it's the reciprocal of 1 over 2, which is 2. Finally, you have cotangent of pi over 3. That's the reciprocal of tangent. So it's 1 over radical 3. And again, we're going to rationalize this number. Multiply both the top and the bottom by radical 3. We obtain radical 3 over 3. And now these are the 6 trigonometric function values of pi over 3, 60 degrees. All right, and then let's do the same thing for pi over 6, 30 degrees. So sine of pi over 3 is SOHCAHTOA. It'll be opposite divided by opposite divided by hypotenuse. So if you look at the triangle, 30 degrees is right here. Opposite is 1, hypotenuse is 2, so it's 1 over 2. And then cosine of pi over 3, that will be adjacent divided by hypotenuse, so it's radical 3 over 2. And then tangent of pi over 3, that will be opposite divided by adjacent. So that would be opposite, it's 1 divided by adjacent, radical 3. And then we're going to rationalize this number. Multiply both the top and bottom by radical 3. We obtain radical 3 over 3. And then we write down the other 3 trig functions. So you have cosecant of pi over 3. It's the reciprocal of sine, so that would be 2. And then we have secant of pi over 3. That's the reciprocal of cosine, so that will be 2 over radical 3. We're going to rationalize this. Multiply both the top and the bottom by radical 3. That leads to 2 radical 3 over 3. And finally, cotangent of pi over 3 is the reciprocal of tangent, so that will be I'm going to use this number right here. So it will be radical 3. Okay, so this will be the 6 trigonometric function values of pi over 6. Pi over, yeah, it should be pi over 6. Pi over 6. I did a mistake right here, so it should be pi over 6. Okay, pi over 6. All right, and then we have these 6 functions values. Put them side by side, and let's see how the results are related, right? So we do see some similar values. If you look at, let's say, let's just look at 1 over 2. Right? 1 over 2 is easier to identify. So for pi over 3, the 1 over 2 is the cosine. And then for pi over 6, the 1 over 2 is the sine. And they are connected, right? As you can see right here, they're connected. They're the same value. And then let's do another one. Radical 3 over 2. Radical 3 over 2, for pi over 3, it's the sine. And then for pi over 6, it's the cosine, right? So they are the same. They are the same. And of course, you could find other ones as well. But in general, we do have a lot of trigonometric properties. This is one of them. It's called the co-identity. The two angles that we're looking at, which is the pi over 3 and pi over 6, they are complementary of each other because they add up to 90 degrees. They're in the right triangle, same right triangle. So there are some properties connecting them. We are going to summarize these properties in practice 3. So cofunction identities, that's what the name is, cofunction identities. Let's write them down. I'm going to write it in red. So if you're given sine of t, then you could rewrite this using cosine. And the angle will be 90 degrees minus t. So this is basically the same that we did earlier about the pi over 3 and pi over 6. So remember, pi over 3 and pi over 6, they add up to 90 degrees. The sine of pi over 3, as you can see right here, is the same as cosine of pi over 6. And that's basically showing you this first cofunction identity. Sine of t is equal to cosine of pi over 2 minus t. And if you don't like this pi over 2, you could convert it to 90 degrees, okay? So this pi over 2, if you don't like it, you could write it as 90 degrees. I think for easier demonstration, I'm going to use 90 degrees for the remaining cofunction identities. So the next one is cosine of t. It's going to be sine of 90 degrees minus t. And then tangent of t. Tangent, if you look at the calculations that we have, let's say radical 3, and let's find a radical 3 on the other side, which is right here. So as you can see, they are connected. It's tangent and cotangent. So the cofunction identity, tangent of t will be cotangent of 90 degrees minus t. All right. And then, of course, the other 3 will also have its own versions. For the sake of time saving, we're going to just write them down. We're not going to look at the values on the left-hand side. But if you're interested, you could look at the values that we computed on the left-hand side. You will be able to verify them. All right, so these are the cofunction identities. I would say the first 3 are the most used ones because they're the 3 main trigonometric functions. Let's do the problem of practice 3, right? Problem of practice 3 says, if sine of t is 5 over 12, what is cosine of pi over 2 minus t? Right, so let's write it down. Cosine of pi over 2 minus t is, so we're going to use this first one that I write over here, right? Cosine of pi over 2 minus t is sine of t. So this is equal to sine of t. And what is sine of t? 5 over 12. So that's the answer. And that's how you can use the cofunction identity to sometimes solve problems. even if you don't know what the triangle looks like. Okay, that's the first page. We're going to move on to the second page. Example 4. A right triangle has one angle of 30 degrees, whose opposite side has a length of 7. Find the unknown sides of the triangle. Let's first do the right triangle. I'm going to graph a right triangle. All right, and then I'm going to label the angle. So we have this 90 degrees, and then one of the angle is 30 degrees. This one looks like a 30 degrees, so I'm going to mark it as 30 degrees. And I'm going to label the names of the sides, right? So you have the opposite, you have the adjacent, and then you have the hypotenuse. Do we know the values? It says the opposite side has a length of 7. So this side is 7. They want you to find the other two sides. Okay, so the other two sides. So how do you do this one? You definitely need to know what this triangle is, right? So if one of the angles is 30 degrees, can you find the other angle? You know that all the angles in a right triangle or in a triangle, they add up to 180 degrees. We know two of them, right? 30 and 90. They add up to 120. 180 subtract 120. That's how you know this one has to be 60. And what's this triangle? This is the 30, 60, 90 triangle. It's the special right triangle. We know the ratios, right? We know the ratios. So let's actually put it right above. We know the ratios. You could go to the previous page. I have it right here. The ratio is right here. So the 30 degrees, 60 degrees, and 90 degrees. The ratio is 1, 2, radical 3. And now we're going to look at the triangle that we have. So the side opposite 30 degrees is 7. And they do form proportionally, which means they are similar triangles. So what you can do is I can simply multiply this one by 7. And that will give me 7 in the triangle that we have. Since you multiply one side by 7 and you want to make sure the ratios are the same, we're going to multiply all the other numbers by 7 as well. And that's how you get the other two sides. So first of all, the hypotenuse, right? We calculate it to be 2 times 7, and that's 14. Let's move this a little bit to the center. Okay, and then we also have the adjacent, right? Adjacent, if you look at the graph, it's 7 times radical 3. So that is 7 radical 3. 7 radical 3. And those are the two sides, and that's it. So you could totally use the special right triangle and the proportional ratio to figure out what the two remaining sides are. And of course, you could also use the SOHCAHTOA, the formulas, to find them out, which involves more algebra. But I think this is probably the better way to do it. Okay, practice 4. A right triangle has one angle of pi over 3 and a hypotenuse of 20. Find the unknown side of the triangle. All right, so let's do a visualization of this triangle. And I should probably put it in the center, right? Let's move it. I'm going to put it in the center. And then we have the 90 degrees. And we also have pi over 3. So what's pi over 3? It's 180 divided by 3, which is 60 degrees. So I'm going to label it right here. This is pi over 3, or 60 degrees. And the hypotenuse is 20. So I'm going to label it 20. You're going to find the other two sides. So same thing, right? We're going to use the 30, 60, 90 special right triangle. Let's do one as well. And I'm going to do the ratios. So this is 30 degrees. This is 60 degrees. And you have 90 degrees. The ratio is 1, 2, and radical 3. And then you look at these two triangles, try to make them the same. So according to my graph, I need to multiply the hypotenuse by 10. All right, that's how you get 20. So you're going to multiply the base by 10, the height by 10. So as a result, our base will be 10, and our height will be 10 radical 3. And that's it. Okay, the last section is applications. We have 2 word problems. Example 5. To find the height of a tree, a person walks to a point 30 feet from the base of the tree. She measures the angle of elevation of 57 degrees. Find the height of the tree. So trigonometry is usually used in a lot of architecture, construction work, engineering work, where you have to do a lot of measurements. And this will be one example of how you could use trig to measure, let's say, the height of a tree. And I do have a visual at the bottom showing you what those 2 kinds of angles meant, because this question they talk about angle of elevation right here, right? So what is the angle of elevation? It's basically looking at an object from where you stand and you're looking up, and the angle between how you look up and the ground is defined as the angle of elevation. So in this graph, if you look at the graph right here, you have the angle of elevation. So let's say you're standing right here at this point, you're looking up at the top of the tower or the tree, and the way you look, right, this and the ground have 2 sides, and in between, this angle is the angle of elevation. Similarly, what is the angle of depression, right? Angle of depression, you're not at the bottom of the tower anymore, you're at the top, and you're looking down in this way. And this will give you one side. The other side is the horizontal side from where you're standing or where you're at. So this is the horizontal line. And the between gives you an angle. This angle is called the angle of depression. All right, so this is the angle of depression. Okay, now we know what they are. We could do a visual of this, right? So basically, I'm just changing this tower to a tree. So I have a tree right there, and then it says that you are 30 feet away from the base of the tree. So let's say this is the base of the tree, and this is where you are, right? You're here, and then it's 30 feet in between you and the base of the tree. They also said that the angle of elevation is 57 degrees. So this is 57 degrees. And of course, we have a right triangle right here. So let's actually visualize the right triangle. We have this right triangle. We have the 90 degrees right here. And you have the 57 degrees. So you could find the other angle if you want. But I don't think we need that. So they want you to find the height of the tree. So what's the height of the tree? It's this side, right? That's the height of the tree. Actually, let's not use the symbol h, because you might be confused with the hypotenuse. So this side, the height of tree, is basically the opposite side, right? I'm going to use opposite. Why do I use opposite? Is because I'm looking at 57 degrees. And the opposite side of 57 degree is this side, which is the height of the tree. So that's why I use OPPO to label the height of the tree. And then we also know the adjacent, right? So this is the adjacent. Let's write that as well. This is ADJA. And then how do you solve this problem? You're going to look at the SOHCAHTOA and see which trig function actually uses opposite and adjacent. So let's go to the first page. Usually you just use one of these 3. You don't need to consider the other 3. And if you look at one of these three uses opposite and adjacent. Can you identify which one it is? Yes, right? It's the tangent. So as you can see, tangent is opposite divided by adjacent. Let's use that one. So you're going to do tangent of 57 degrees, because that's the angle, is opposite divided by adjacent, opposite divided by adjacent, and then you're going to plug in the values. So opposite is what we need. It's the height of the tree, right? It's the height. And adjacent is 30 feet. So we have this function. We have this, not function, sorry. We have this equation. So it's basically saying that tangent of 57 degrees equals height of the tree divided by 30. And then to get height, we multiply both sides by 30. And then you obtain that 30 times tangent of 57 is the height of the tree. And then you need to use your calculator, calculate what's tangent of 57 degrees times 30. Make sure that your calculator is set to use numerical degrees. If you're using radians, then you have to convert 57 degrees to radians and then plug into the tangent function, calculate what that is. So I'm going to give you the answers right here. If you calculate it correctly on your calculator, you should get 46.20 approximately. That's the height of your of the tree. And of course the unit, let's add the unit as well. So the unit is feet. Okay, let's look at practice 5. A radio tower is located 325 feet from a building. From a window in the building, the person determines that the angle of elevation to the top of the tower is 43 degrees and that the angle of depression to the bottom of the tower is 31 degrees. And the question is asking how tall the tower is. Let's do a visualization first. So I'm going to do a building. Let's just put the building right here. And I'm going to place some windows on this building. And then we also have a tower. So the tower, we could place it right here. And let's see. I'm just going to graph a tower that looks kind of similar to the tower that's already on the graph, on the paper. So this is what the tower looks like, right? And you have some of the lines. I'm not very good at drawing, but I'm just making it looks like a tower. Okay, once you have the tower, we can actually graph. So we have the ground. This is basically the ground. And let's see where you are, right? So the radio tower is located 320 feet away from the building. And usually if you have graph like this, I usually just use like where you stand in the building and the center of the tower to define the distance. So this is 325. Or you could use like the center of the building. So we're not really talking too much about, I'm not supposed to do that. I don't really talk too much about like where you are, how you define the distance, but usually I'm just gonna say where I'm standing and the center of the tower in between. That's 325 feet. And let's say you are standing like right here, right? That's where you are. From a window in the building, a person determines that the angle of elevation to the top of the tower is 43 degrees. So this person will look upwards. So look upwards, and that's the top of the tower. I should probably make the tower a little bit taller, but it's fine. Actually, why don't we make the person stand on the second floor, right? So if the person's on the second floor, I think it makes more sense. So this person will look up at the top of the tower. And the angle of elevation is 43 degrees. So let's actually graph that. So that means you have to also do a horizontal line. And the angle of elevation is 43 degrees. So this is 43 degrees. And then we also have the angle of depression. the angle of depression to the bottom of the tower is 31 degrees. So this person will also be looking down. So this will be the angle of depression right here, and that's 31 degrees. All right, and once you have this graphed, then we can see in this graph we have two right triangles. The first right triangle has this right angle right there. And then the second right triangle has this right angle right here. These are the two right triangles. They share a common side, which is the blue line that I graphed. This blue line represents the distance between the tower and the building. And it's 325. So let's also label that. This is 325. Okay. And the question is asking you how tall the tower is. And that is the height of the tower. And according to the graph, the height of the tower consists of two parts. The first part is this piece, right? This piece, which is inside the top right triangle. And then you also have the bottom piece, this part. This part is the part of the bottom right triangle. And if we could find out those two sides in each of the right triangle, then we can add them up, and that will give you the height of the tower. So that's the plan. To simplify the graph a little bit, I'm going to separate those two right triangles. I'm going to graph right here. So this is the top right triangle, and I know that this is 43 degrees, and this side is 325. We're looking at this side. And for the bottom right triangle, it will look like this. We know that the angle is 31 degrees right here. And this side is 325 feet. We want to know what this side is. Once we know the two question marks, we add them up. That's the height of the tower. So let's study each of the right triangle and see which trig function we're going to use. In the first right triangle, we have 43 degrees, so let's label the two sides. The question mark is the opposite side, and the 325 is the adjacent. So this is very similar to example 5. The trig function that involves these two sides are tangent. Let's write it down. So it will be tangent of 43 degrees, right, equals opposite divided by adjacent. So that would be, let's make this x1. So that would be x1 over 325. To find out x1, we multiply both sides by 325. And we can obtain x1 is 325 times tangent of 43 degrees. And then if you use your calculator to calculate, you should be able to get a number for that. I'm going to save that for you guys. Let's look at the second right triangle. Second right triangle, it's going to be very similar. I'm going to define this question mark as our x2. And then I'm going to write down the labels. So looking at 31 degrees, x2 is the opposite, and 325 is the adjacent. And the trig function that involves those two sides are again tangent. So tangent of 31 degrees equals opposite, which is the question mark, or x2, divided by adjacent, that's 325. And to get x2, we multiply both sides by 325. And that means x2 is 325 times tangent of 31 degrees. To get the height of the radio tower, we add x1 and x2, right? So you calculate those two pieces separately, add them together. I do recommend that you enter the whole thing into your calculator. So on your calculator, you could just enter 325 times tangent of 43 degrees. Make sure that your setting is set to degrees. And then plus 325 times tangent of 31 degrees. And then you hit enter. That will give you a more accurate answer. So if you keep 2 decimal places and calculate it correctly, it will be approximately 498.35 feet. So give it a try with your calculator, see if you could get that number. If you didn't get that number, chances are your setting is set to radians. So you can either change the angles to radians, or you could change the settings on your calculator. And that's practice 5. Okay, thanks for watching this video.